So when you ask an AI to go find something in your documents, what is actually going on under the hood? Well, today we're going to pull back the curtain on the very first and maybe the most important step in that whole process. It's called indexing. Let's get into it.
Okay, so let's just start with the main problem here. We have all this information, right? You've got reports, emails, PDFs, you name it. But a computer can't just, read that text like you and I can. It needs a totally different way to process all that messy human language and find the exact piece of info that answers your question.
And the solution to this big problem is, honestly, it's pretty clever. The whole idea is to take all of that free-form text and translate it into a structured, numerical format. We are literally turning our words into numbers that a machine can finally understand and work with.
And this quote from Lance at LangChain just nails why we do this. See, once your documents are represented as these lists of numbers, we call them vectors, comparing them is no longer a language problem, it's just a math problem. And AI can now instantly see how similar two pieces of text are, which is something that's, basically impossible to do with raw text itself.
Now, this idea of turning text into numbers, or vectorizing it, it's not brand new. Over the years, there have really been two main ways to tackle this, and each one has its own philosophy about what's actually important inside a block of text.
So on one hand, you've got the older statistical methods. These create what we call sparse vectors, and they basically just count how often words appear. I mean, they're useful for sure, but they're focused on frequency, not really the meaning. But on the other hand, you have the modern way of doing things, machine-learned embeddings. These dense vectors are actually trained to understand the semantic meaning and the context of the words. And that is a huge game changer, and it's the method we're going to focus on.
All right, so let's walk through how this modern embedding-based indexing process really works, step by step. Think of it as a three-part journey to build a perfectly searchable library out of all your information.
But wait, before we jump into the steps, we have to lock in this one super important term, embedding. And embedding is the goal here. It's that final output. It's a compressed, fixed-length list of numbers, a vector, that's been machine-learned to act like a numerical fingerprint for the meaning of a piece of text.
So here's how it goes down. First, you take your big documents and you split them up into smaller, more manageable chunks. You pretty much have to do this because the models have a limit on how much text they can look at one time. Second, each one of those little chunks gets fed into an embedding model, and out comes its unique numerical fingerprint. And finally, all of these vectors get organized in a special kind of database called a vector store. And in there, every single vector is carefully linked back to the original text it came from.
Okay, so that's the theory. But you know me, I think it always helps to make these abstract ideas as concrete as possible. So let's actually look at what this whole process produces in a real-world example.
Right, so we've been throwing around this idea of a list of numbers or a vector. But what does that even mean? I mean, what are we really looking at when we say that a piece of text has been embedded?
Here it is. For a popular model like the one from OpenAI, every single piece of text, whether it's your question, a chunk from a document, anything, it gets converted into a list of exactly 1,536 numbers. That precise, fixed length, that's the whole key.
And this is the whole point. The system now has a universal mathematical language for meaning. Your question becomes a list of 1,536 numbers. Every chunk of every document is also a list of 1,536 numbers. And suddenly, finding the most relevant information isn't about reading text anymore. It's about finding the list of numbers that is mathematically closest to your question's list of numbers.
And just like that, the heavy lifting is done. The documents have been loaded, they've been split up, and they've been embedded into this perfectly structured, searchable index of numbers. Everything is prepped and ready for the next phase.
So we've built this incredible, organized library where every single idea has its own numerical address. But that leaves one final, really exciting question. How does the AI search through potentially millions of these number lists in a fraction of a second to find the perfect match? Well, that process is called retrieval. And we're going to break that down in the next explainer.